Now the question is longest palindromic subsequence. You are given a string S and you have to find the longest palindromic subsequence in length S. Now the clean approach is 2D dynamic programming over the substrings. So you let dp of ij be the length of the longest palindromic subsequence within S of I, assume your pointer is over here, all the way till S of j. So if your S of I is equals to S of j, which I'm checking over here, the two matching characters wrap around whatever is best inside. So dp of ij will be equal to dp of I plus 1 and j minus 1, and you add plus 2. Otherwise, you drop one end and you choose the max, so which I'm doing over here. I'll also now run through the code, but there are two solutions. This first one is your classic DP, which has the time complexity O of n square and the space complexity O of n square again. Now, I've also done the second solution, which where I've trimmed down on memory, and this has trimmed it down to O of n, because I will only keep two rows since each cell only needs the row below it. But first, I'm going to start with the first solution. So you start with n equals to length of s, where we are storing the length of the string, so we don't have to recompute it. Then you are creating a DP, so n times n, which is a grid filled with zeros. Then for I in range, n minus 1, minus 1, minus 1. So this takes in three parameters: start, stop, which is exclusive, and then this is the step. So we are going backwards. dp of I equals to 1. This is the base case. So a substring of a single character is a palindrome of itself, so length 1. Then for j in range I plus 1 up till n. So for the current row I, loop j from I plus 1 up to n minus 1. So this is not inclusive. So we start at I plus 1 because j is equal to I case was already handled by the base case. Then if S of I is equals to S of j, you check whether the two characters at the end of the current window match. In that case, dp of ij equals to dp of I plus 1 and j minus 1 plus 2. So if the ends match, both the characters can sit on the outside of the palindrome. So we take the best palindrome from the inner substring. So the inner substring will be I plus 1 and j minus 1. And then you add 2 for this matching pair. So this I plus 1 is technically the row below, and j minus 1 is the column on the left. Or else, if the ends don't match, they can't both be on the outside of the same palindrome. So at least one must be excluded. And we try dropping the left, which is dp of I plus 1 j, and dropping the right end, which is dp of I j minus 1. And we keep whichever gives the longest result. And over here, we return dp of 0 n minus 1. So the answer for the whole string is the window spanning from index 0 to n minus 1. That is the top right of the grid. So this is the first solution, but now I'll run you through the second one as well. So this is identical, the length of the grid. Previous equals to 0 times n. So over here, I've put a comment that this is dp of I plus 1 technically. So this is a single row that stands in for dp of I plus 1, because the row below the one we are currently computing is that. So before the loop starts, when we are about to compute row, equals to n minus 1, there is no row below it, so it's all zeros, and that matches the 2D grid where everything below the diagonal was 0 anyway. So this comment, dp of I plus 1, is just a mental anchor. So wherever you see previous, you can read it as the row for I plus 1. So for I in range, n minus 1, minus 1, again, identical. Current equals to 0 times n. So this is a fresh filled row of zeros. It is representing dp of I. So the row we are about to compute in this iteration. We make a new list each time rather than reusing one, which keeps things clean. Then cur of I equals to 1. So this is the base case exactly as before. Then for j in range I plus 1, n, again identical. If s of I equals to s of j, cur of j equals to previous j minus 1 plus 2. So this is the translated version of this line. So the only change is technically the meaning. So this is dp of ij, cur of j, so the current row, dp of I plus 1, j minus 1. So previous j minus 1, the row below and the one column left, and previous was technically dp of I plus 1. So same meaning, the ends match. So take the best palindrome from the inner window and add 2 for the matching pair on the outside. That's what we are doing over here. Else, cur of j equals to max of previous j and cur j minus 1. So this is the translated version of this code. So you drop from the left end over here. So comes from the row below and same column. And this is us dropping from the right end, so comes from the current row, one column left. Then previous equals to current. So we have finished computing row I. So before moving up to row I minus 1, we make the current row become the row below for the next iteration. And next time around, cur will be a brand new row, and this finished the row for the plays the role of previous. So this one line is what let us march up the grid with only 2 rows in memory instead of n. And then return previous of n minus 1. So after the loop finishes, the last row we computed was I equals to 0, and we just assigned it into previous. So previous holds what solution 1 called dp of 0. And previous n minus 1 is dp of 0 n minus 1. So the answer for the full string. And this is the end.